Artificial Intelligence and Machine Learning course. Artificial intelligence, AI, and machine learning, ML, are two of the most transformative technologies of our time. AI systems are already being used to solve complex problems in a wide range of industries, including healthcare, finance, and manufacturing. ML is a subset of AI that allows systems to learn from data and improve their performance over time. In this course, you will learn the fundamentals of AI and ML, including the different types of machine learning, the machine learning process, supervised learning, unsupervised learning, reinforcement learning, deep learning, natural language processing, computer vision. You will also learn how to apply AI and ML to solve real-world problems. Why you should study this. AI and ML are in high demand, and there is a shortage of qualified professionals in these fields. By studying AI and ML, you can position yourself for a successful career in a variety of industries. Knowledge of AI and ML can benefit you in a number of ways, including higher earning potential. AI and ML professionals are among the highest paid in the tech industry. More job opportunities. The demand for AI and ML professionals is growing rapidly. Module 1. Introduction to Artificial Intelligence and Machine Learning. Imagine a world where computers can think and learn like humans. Where machines can diagnose diseases, design new products, and even write creative content. This is the world of artificial intelligence, AI, and machine learning, ML. What is artificial intelligence? AI is a broad field of computer science that seeks to create intelligent machines. AI systems are able to learn from data and improve their performance over time. Examples of AI: self-driving cars, intelligent personal assistants, spam filters, product recommendation systems, voice recognition systems, fraud detection systems. What is machine learning? ML is a subset of AI that focuses on developing algorithms that can learn from data and make predictions without being explicitly programmed. ML algorithms are used in a wide range of applications, including spam filtering, product recommendation, and image recognition. How does machine learning work? ML algorithms are typically trained on a set of labeled data. The labels indicate the correct output for each input. Once the algorithm is trained, it can be used to predict the output for new inputs. Examples of machine learning: a spam filter that learns to identify spam emails by analyzing the content of past emails. A product recommendation system that learns to recommend products to users by analyzing their past purchases and browsing behavior. An image recognition system that learns to identify objects in images by analyzing a large dataset of labeled images. The different types of machine learning. There are three main types of machine learning. Supervised learning. In supervised learning, the algorithm is trained on a set of labeled data. The labels indicate the correct output for each input. Once the algorithm is trained, it can be used to predict the output for new inputs. Unsupervised learning. In unsupervised learning, the algorithm is trained on a set of unlabeled data. The algorithm must find patterns in the data without any prior knowledge of the correct output. Unsupervised learning algorithms are often used for clustering and dimensionality reduction. Reinforcement learning. In reinforcement learning, the algorithm learns by interacting with its environment. The algorithm receives rewards for taking actions that lead to desired outcomes and penalties for taking actions that lead to undesired outcomes. Reinforcement learning algorithms are often used in video games and robotics. The applications of artificial intelligence and machine learning. AI and ML are used in a wide range of applications, including healthcare. AI and ML systems are being used to diagnose diseases, develop new treatments, and personalize care for patients. Finance. AI and ML systems are being used to detect fraud, predict market trends, and automate investment decisions. Manufacturing. AI and ML systems are being used to improve product quality, optimize production processes, and predict demand. Retail. AI and ML systems are being used to recommend products to customers, optimize pricing, and manage inventory. Transportation. AI and ML systems are being used to develop self-driving cars and trucks, and to optimize traffic flow. Education. AI and ML systems are being used to personalize learning experiences for students and to provide feedback on student work. AI and ML are two of the most transformative technologies of our time. AI and ML systems are already being used to solve complex problems in a wide range of industries. Module 2. Machine Learning Fundamentals. In this module, we will cover the fundamentals of machine learning, including data and features, model selection and evaluation, overfitting and underfitting, and regularization. Data and features. The first step in any machine learning project is to gather data. The data should be relevant to the problem you are trying to solve. For example, if you are trying to build a spam filter, you would need to gather a dataset of emails, labeled as either spam or not spam. Once you have gathered your data, you need to clean it. This involves removing any errors or inconsistencies in the data. For example, you might need to remove any emails that are missing a sender or subject line. Next, you need to extract the features. Features are the characteristics of the data that will be used to train your machine learning model. For example, some features of a spam filter might be the email sender, the email subject, the email body, and the presence of certain keywords. Model selection and evaluation. Once you have extracted your features, you need to select a machine learning model. There are many different types of machine learning models, each with its own strengths and weaknesses. Some common machine learning models include linear regression, logistic regression, decision trees, and support vector machines. Once you have selected a model, you need to train it on your data. This involves feeding the model the features and the target variable, e.g., spam or not spam. The model will learn to predict the target variable based on the features. Once the model is trained, you need to evaluate its performance on unseen data. This can be done by splitting your data into a training set and a test set. The training set is used to train the model, and the test set is used to evaluate the model's performance on unseen data. Overfitting and underfitting. Overfitting and underfitting are two common problems in machine learning. Overfitting occurs when the model learns the training data too well and is unable to generalize to unseen data. Underfitting occurs when the model does not learn the training data well enough. There are a number of things you can do to prevent overfitting, such as using a simpler model, reducing the number of features, regularization. Regularization is a technique that can be used to prevent overfitting. Regularization works by penalizing the model for having complex relationships between the features and the target variable. This encourages the model to learn simpler relationships, which are more likely to generalize to unseen data. There are a number of different regularization techniques, such as L1 regularization, L2 regularization, and elastic net regularization. Here is a more in-depth discussion of each of the topics covered in this module. Data and features. When gathering data for a machine learning project, it is important to keep the following in mind. The data should be representative of the population you are interested in. The data should be clean and free of errors. The data should be labeled if you are using a supervised learning algorithm. Once you have gathered your data, you need to extract the features. Features are the characteristics of the data that will be used to train your machine learning model. It is important to select features that are informative and predictive of the target variable. Model selection and evaluation. There are many different types of machine learning models, each with its own strengths and weaknesses. When selecting a model, it is important to consider the following factors: the type of problem you are trying to solve, the size and complexity of your data, the availability of computational resources. Once you have selected a model, you need to evaluate its performance. This can be done by splitting your data into a training set and a test set. The training set is used to train the model, and the test set is used to evaluate the model's performance on unseen data. Overfitting and underfitting. Overfitting occurs when the model learns the training data too well and is unable to generalize to unseen data. This can happen if the model is too complex or if the training data is too small. Underfitting occurs when the model does not learn the training data well enough. This can happen if the model is too simple or if the training data is too noisy. Regularization. Regularization is a technique that can be used to prevent overfitting. Regularization works by penalizing the model for having complex relationships between the features and the target variable. This encourages the model to learn simpler relationships, which are more likely to generalize to unseen data. Here are some examples of regularization techniques. L1 regularization. L1 regularization penalizes the model for having large coefficients. This forces the model to learn a sparse model, with only a few important features. L2 regularization. L2 regularization penalizes the model for having squared coefficients. This forces the model to learn a smoother model, with coefficients that are more evenly distributed. Elastic net regularization. Elastic net regularization is a combination of L1 and L2 regularization. It penalizes the model for having both large and squared coefficients. The amount of regularization to use is a hyperparameter that must be tuned. This can be done by using a validation set. Suppose we are trying to build a spam filter. We have a dataset of emails, labeled as either spam or not spam. We extract the following features from each email: email sender, email subject, email body, presence of certain keywords. We train a logistic regression model on our data. However, the model overfits to the training data. This means that the model performs well on the training data, but it performs poorly on unseen data. We can use regularization to prevent the model from overfitting. We can use L1 regularization, which will force the model to learn a sparse model. This means that the model will only learn a few important features. We train the model again with L1 regularization. The model now performs well on both the training data and the unseen data. That brings us to the end of the module 2. See you in the next module.